Analog to digital converter block schematic. The ADC converts an analog input voltage to a 10-bit digital value through successive approximation. The ATmega32 features a 10-bit successive approximation ADC. The ADC is connected to an 8-channel analog multiplexer which allows 8 single-ended voltage inputs constructed from the pins of port A. The single-ended voltage inputs refer to 0V, G and D. Internal reference voltages of nominally 2.56 V or AVCC are provided on chip. The voltage reference may be externally decoupled at the AREF pin by a capacitor for better noise performance. AVCC or an internal 2.56 V reference voltage may be connected to the AREF pin by writing to the REF SN bits in the ADMUX register. ADC control and status register ADCRA. The ADC generates a 10-bit result which is presented in the ADC data registers, ADCH and ADCL. Auto trigger source selector. These bits select the voltage reference for the ADC. The ADC generates a 10-bit result which is presented in the ADC data registers, ADCH and ADCL. By default, the result is presented right adjusted, but can optionally be presented left adjusted by setting the Adler bit in ADMUX. The analog input channel and differential gain are selected by writing to the MUX bits in ADMUX. Differential channels in TQFP package only. Any of the ADC input pins, as well as G and D and a fixed bandgap voltage reference, can be selected as single-ended inputs to the ADC. Writing this bit to 1 enables the ADC. By writing it to 0, the ADC is turned off. In single conversion mode, write this bit to 1 to start each conversion. In free running mode, write this bit to 1 to start the first conversion. When this bit is written to 1, auto triggering of the ADC is enabled. The trigger source is selected by setting the ADC trigger select bits, ADTS in sphere. This bit is set when an ADC conversion completes and the data registers are updated. When this bit is written to 1 and the I bit in SREG is set, the ADC conversion complete interrupt is activated. These bits determine the division factor between the XTAL frequency and the input clock to the ADC. If ADC in ADCRA is written to 1, the value of these bits selects which source will trigger an ADC conversion. If ADC is cleared, the ADTS2:0 settings will have no effect. Bring these component from library. It is recommended to watch video familiarity with the Proteus software environment. Capacitor, inductor, ATMGA32, LCD, potentiometer, set ADC power supply and reference voltage to 5 volts. It is recommended to watch video AVR microcontroller tutorial alphanumeric LCD and AVR ATMGA32. LCD connected to port C, pins 0 to 6. We use labels for connections. It is recommended to watch video Proteus tutorial the property assignment tool. We want scan all 8 ADC channels. Run CodeVision. Enable analog to digital converter. The voltage of the AREF pin, as the reference voltage. Operating frequency of ADC, 62,500 Hz. Enable ADC interrupt. ADC auto trigger source set to the free running mode. Scan all ADC input from 0 to 7. Enable external interrupt 0 sensitive to falling edge. LCD connected to port C, pins 0 to 6. EC. The external interrupt 0 and ADC interrupt are enabled. Registers of ADC. Global interrupt is enabled. LCD configured on port C. Include the stlib.h file, for the IDO function. Define the necessary variables. First underscore ADC underscore input is defined as 0 and last underscore ADC underscore input is defined as 7. That means channel 0 to channel 7 will scanning. ADC underscore data is defined for save the ADC result, contain 8 unsigned integers. Here is the reference voltage of the AREF pin, and right adjusts the result are selected. Variable input underscore index for addressing 0 to 7. ADCW contain all 10 bits of result. These two lines ensure that the input underscore index varies between 0 and 7. This line set at mux. Delay needed for the stabilization of the ADC input voltage. Increase to 300 microsecond. This line start an ADC conversion. The IDO function converts the integer ADC underscore data 0 to characters in string S0. Show the result on LCD. String variables contain 6 characters. Programming the ATNGA32. Another example. We want to scan one channel and triggered by external interrupt 0. It is recommended to watch video AVR microcontroller tutorial, external interrupt. Change this to 0 because we just want to scan channel 0. Disable or remove this because we want triggered ADC by external interrupt 0. Pin 2, a port D, input with pull-up resistance. It is recommended to watch video AVR microcontroller tutorial, ATNGA32 input and output configuration. Write this bit to 0 because we just want ADC to be triggered by external interrupt 0. Set this bit to 1, until each conversion start by external interrupt 0. Check external interrupt 0, is enabled. Disable these lines, we do not need them in this project. The ADC only works when an external interrupt 0 occurs. If you are interested in the topics of this channel, do not forget to subscribe. Thanks for watching.